Welcome, everyone. Today, we're going to break down a really sophisticated framework for forecasting short-term inflation. What makes this so interesting is that it's designed specifically for the Indian economy, which, as you know, has its own unique challenges.
Okay, so here's our game plan. We'll start with the core problem, then look at this kind of clever heterodox solution. After that, we'll unpack the three-layered framework, see how it actually performs in the real world, and then wrap up with the key takeaways you absolutely need for your exams.
So, first things first, let's really get a handle on the fundamental problem that this whole model was built to solve.
Well, for any central bank that's trying to target inflation, the main headache is this constant trade-off between the different kinds of models they have at their disposal.
And this slide really nails the dilemma. On one side, you've got these data-heavy models, think machine learning, that are fantastic for predicting what's going to happen next week or next month, super accurate in the short term. But they're not great for analyzing long-term policy changes. On the other side, you have these big structural models. They're built for policy analysis, but they often miss the mark on near-term forecasts. You see the problem? There's a huge gap in the middle.
So, the big question is, how do you bridge that gap? And that leads us to this really innovative kind of hybrid approach.
I love this phrase because it perfectly sums up the goal. You want to create one single framework that can connect the immediate data-driven future with that longer-term economic equilibrium. You need to make the horizons meet.
And this is a key word you absolutely have to remember: heterodox. A heterodox approach isn't stuck in one way of thinking. It's pragmatic. It basically takes the best bits from different methods and combines them to build a stronger, more useful forecasting tool. It's that bridge we were talking about.
All right, let's get into the architecture of this thing. It's called the Short-Term Forecasting Model, or SFTM for short. Let's see how it actually builds that bridge. So, the model is engineered in three distinct layers. You've got the input, the model, and the output. Now, for your exams, a really simple way to remember this is the mnemonic IMO. IMO. Let's break down each one.
First up, the input layer. This is where you gather all the raw materials. We're talking historical data for 33 different CPI components, key macro variables like the output gap, and two really important concepts: nowcasts and benchmark forecasts.
So what on earth is a nowcast? Well, think of it as our best possible guess of what's happening right now. It's built using all the real-time, high-frequency data we can get our hands on. Market prices, surveys, you name it. This is the starting point of our bridge, our anchor in reality.
And on the other side of that bridge, that's where the benchmark forecasts come in. This is where inflation is probably headed in the medium term. And it's not just one model's opinion, it's generated by combining forecasts from 216 different models. So this is our destination, our long-term guidepost. Okay, that brings us to the second layer, the model layer. This is the engine room. It does the heavy lifting. It takes the starting point, the nowcast, and calculates the most likely path to the destination, the benchmark. It considers all sorts of things, like how price shocks in one area spill over into others and how everything is linked to the broader economy. And just to give you an idea of how complex this engine is, check this out. We're talking about a system with 134 equations and 89 parameters, all being solved at the same time. This is a serious piece of analytical machinery. And finally, the third layer, the output layer. This part is pretty straightforward. It just takes all the complicated results from the engine and translates them into the headline inflation numbers that policymakers and you and I can actually understand and use. Okay, so we've built the machine. Now, what can it actually tell us about the real economy? Let's look at some of the results. The model shows that if the currency depreciates by 10%, that leads to about an 80 basis point increase in headline inflation over the course of a year. That's a direct hit on the cost of living.
What about when the economy heats up? Well, if demand strengthens and the output gap increases by 1 percentage point, the model predicts that inflation will rise by about 20 basis points. And here's a really big one. If diesel prices go up by 10%, that can push headline inflation up by a massive 90 basis points over the next 12 months. You can really see how fuel costs ripple through the entire economy. So, the big question is, does it actually work? Is it accurate? This chart says it all. That STFM bar is lower than the benchmark bar. And in this case, lower is better. It means the model's forecasts in the near term are significantly more accurate, all because it smartly uses those nowcasts as its starting point.
Okay, let's get to the most important part for your preparation. We're going to consolidate everything we've just talked about into one single comprehensive summary.
So, listen up. Here are the crucial points. First, the core concept. It's a heterodox model that acts as a bridge. Second, the architecture. Remember the mnemonic IMO, input, model, output. Third, the key inputs. You have to know the difference between nowcasts, which are our starting point, and benchmark forecasts, which are our destination. And fourth, and this is critical for your exam, memorize these numbers. A 10% currency depreciation, that's about an 80 BPS inflation increase. A 1 percentage point output gap increase, that's 20 BPS. And a 10% diesel price hike, that's a huge 90 BPS increase. Get those down cold. This framework really is a powerful new lens for looking at inflation. And it leaves us with a final thought, a really big one. As our ability to generate these super accurate real-time nowcasts gets even better, what new possibilities does that open up for how we guide our economies? It's something to think about.